Hey guys, Mr. Papanik here. Thanks for checking out the video. I guess you really don't have a choice. I should be back in school soon. Hope everybody's doing well. So today's worksheet, you guys are looking at computing the average rate of change. I started by just writing down number 1 on the page. The instructions tell you to compute the average rate of change for the function given over the given interval. So the function given, some of them are quadratics, like number 1. Notice you've got 2x squared plus x plus 1. So that's a quadratic. You know that's going to be something like some kind of parabola. And then it says over the interval. So this is a closed interval. What we're saying is we're looking from the left to right, x being -2 to -1. Right? So if -2 is here, we're going to go from -2 all the way over to -1. We're trying to find the average rate of change of this function. The reason we can only do average rate of change right now is it's a quadratic function, right? So it's a curve, which has different rates of change at different points. You guys will learn a lot about that in calculus, but right now what we're doing is kind of setting the table for that. You're going to find that this is a very, very simple process, but setting this up now will make calculus a lot better down the road. So what we're doing is we're first going to try to find or recall what rate of change is, right? Rate of change is actually slope, right? So if we're looking at slope, right, we're talking about the difference in y, or the change in y over change in x, right? So we can actually get that by taking the y value of 1 point, subtracting the y value of the second point, and then doing the same thing for the x values of those points, right? So that's algebra 1, right? So when you have these points x1 comma y1, and the second point was x2 comma y2, right? And those kinds of problems just seem so ridiculous, but they're so meaningful down the road, and we're getting close to that point down the road. So what we're going to do is we're going to take this function, and we already know one of the y values, right? So in essence, when you see that you've got -2, that can be considered one of your x values, right? That -2, we can call that x1, right? And then you've got that other one, you've got -1, that's the end of your interval. That can be considered your other x value. Right? So the question becomes, well, how do you know what the y value is for each of those? Very, very straightforward. What we're going to do is we're going to evaluate this original quadratic function, or whatever function you're given to begin with. We're going to evaluate that at that value of x. So I know this says y equals, I'm going to change it into f of x equals, and I'm going to simply write this problem, and instead of x's, I'm putting my placeholder, right? Because one of the best things about function notation is you can see that direct link between plugging in an x value to get out a y value, right? So I'm saying if I allow x to be -2 in this function, if I do all this stuff, all this arithmetic, I'm going to know exactly what that y value is, right? So f of -2 is, let's see, that's 2 times 4, right? Because -2 times -2 is 4, minus 2 plus 1, right? So that's 8 minus 2 is 6 plus 1 is 7. So f of -2 equals 7, right? That means that this point right here, x1, y1, is actually the point -2 comma 7, right? Well, we're going to do a very similar thing here for this other guy. We're going to do f of, we'll plug in -1, 2 times something squared, plus that same something, right? We're replacing x with just a placeholder, and then we're going to put the actual x value in. That's the f of -1, right? So f of -1 equals, -1 times -1 is 1, 2 times 1 is 2. So what we find is f of -1 is actually 2. So what that means is this second point, this x2 comma y2, is actually the point -1 comma 2. Right? So this whole idea of average rate of change sounds so fancy. Really, now that we have this established, these 2 points, right, they're defined by that interval. You plug them into the function to get the y values. Now we can simply just find the average rate of change, which is just the slope. Average rate of change. Remember, that's the slope, right? It's the slope between those 2 points because it's an average, it's a linear rate of change. So we're just going to write in, let's see. Remember, it's delta y over delta x. So change in y over change in x. So I'm going to put I'm just choosing to do the orange point first. That's my y value. There's the x value, the corresponding x value. Here's my y value for the green point and the corresponding x value. So when I do that, I get that my average rate of change, 7 minus 2 is 5. -2 plus 1 is -1. That means my average rate of change is -5. So algebraically, it's just a simple matter of computing slope. What this really means, I mean, you guys don't even need to know the exact graph, but it's telling you that if you plugged in -2 for x, right? If you plugged in -2 for x, you would get out 7. So let's see. 1, 2, -2, 1, 2, 3, 4, 5, 6, 7. So if I plugged in -2, I'd get out 7. Right, that's my orange point. Should have done that in orange. And then if I plugged in -1, I'd get out 2. So if I went to -1, I'd get out 2. And remember, this is a parabola, right? So this thing kind of comes down like this. And then, of course, it kind of turns somewhere, right? You guys don't really know exactly where. You could figure it out, but we're not really interested in that right now. We're just finding this average rate of change, right? So what we're saying is, if I were to connect those 2 points, right? If I were to connect those two, that would be my average rate of change. Right here, that ended up being -5. And this one was +1. There's my -5. Hope that helped. Good luck with the rest of the worksheet, and I'll see you all soon.